So in this lecture, we're going to take the next step that I promised in the last lecture. We're going to look at how to factor what I'm kind of calling the generic kind of quadratic polynomial. That's one that actually has a number other than 1 in that a parameter position, something other than 1 in front of the x squared. And we have a procedure for this. Now the procedure, it's a little bigger, right? It's a little bigger than the previous one. But you'll see as we go along, there's some similarities, right? Instead of looking at that c term by itself and looking for numbers that multiply to give me that and add it up to the b term, I'm going to multiply a and c. Then I'm going to do the next 2 steps of the process we learned in the previous lecture. I'm going to write out all the pairs of integers whose product is equal to that number, and I'm going to look for the pair whose sum is equal to the b parameter, the number in front of the x. And this is the term where I think it's going to really be better if we look at an example. I'm going to split the x term into 2 parts based on the pair we came up with. Then I'm going to factor by grouping. Let's look at an example. Right, I want to factor 2x squared plus 9x plus 10. And I'm starting out here doing what I said in step 1. I'm multiplying the a and the c term together. A is 2 and c is 10, so that product is going to give me 20. Now I'm going to start breaking up that 20. I'm going to look for pairs of numbers that multiply to give me 20, and I'm looking for the pair that adds up to 9. Right, so be methodical. Right, I'm going to start at the beginning. 1 times 20 is 20. 1 plus 20 is 21, not 9. 2 times 10 is 20. 2 plus 10 is 12, still not 9. Okay, 3 doesn't go into 20, so I'm going to skip that one. 4 goes into 20. 4 times 5 is 20, and 4 plus 5 is 9. That's the pair that I was looking for because it adds up to that middle term, the middle term's coefficient. Okay, so here's what I'm going to do. I'm going to take that 9x, and I'm going to split it up 4x plus 5x, right? I'm using the 4 and the 5, that pair that I came up with. Now, I can factor this by grouping, right? The end result is going to be this thing, right? How did I get to 2x times x plus 2 plus 5 times x plus 2? Well, if you look at the first 2 terms, the 2x squared plus 4x, I factored a 2x out of there, and I got this part. Then if you look at the second 2 terms, the 5x plus 10, I pulled a 5 out of there, and I was left with 5 times x plus 2. Now I'm going to factor by grouping. Both of these 2 big pieces here have an x plus 2 in them. I'm going to factor that x plus 2 out. Right? That's going to leave me with x plus 2 times the 2x from the first group plus the 5 from the second group, and that's my answer. And that's my final result. That's the factorization of the original polynomial. And one of the nice things about these kinds of questions, super easy to check. Right? Use your FOIL method, however else you like to do it. Multiply that expression out. You should get back to 2x squared plus 9x plus 10. Okay, so I want to take one more example here because it's going to illustrate an important point. And all I did was I changed the middle term from a 9 to a 7. Right, so we're going to start off with 2 times 10 is 20. And I'm going to start, again, splitting that 20 up, looking for a pair of numbers that gives me 7 when I add them together. Right, so I got 1 and 20, that's no good. 2 and 10, that's no good. 4 and 5, that's 9, not 7. Now my next pair would be 5 and 4, right? But I've got that already. We're not going to duplicate. The order of the numbers doesn't matter. So now I'm going to check out the negatives. Negative 1 and negative 20, that gives me negative 21. Negative 2 and negative 10, that gives me negative 12. And I only have one more option. Negative 4 and negative 5, that gives me negative 9. Nothing added up to 7. So what do we do? Well, it depends on where you are in your study of factoring. Most classes, as they're learning this method, if you get to this point where you can't find a pair of numbers that works, my answer would be, the answer your professor or teacher can expect, is that the polynomial is prime which is to say it can't be factored. Now, I feel the mathematician in me, I need to clarify that a little bit. Every polynomial can be factored, right? Every one, if you're willing to push it far enough. Okay. Really, what we're saying at this point is that this polynomial cannot be factored just using integers. In other words, just using nice numbers: 1, 2, 3, -1, -2, -3. It can't be factored if we're willing to go a little further and maybe use irrational numbers. If maybe we're willing to put some square roots in the factors, right? Or maybe we need to really go out on the edge and use complex numbers, imaginary numbers, to do this. We'll talk more about that later on, right? But for now, if you get in this situation where you're stuck and you can't find a pair that works, your answer is going to be that it's prime and can't be factored. Okay, so looking ahead, we're going to continue our discussion of factoring, right? Looking at some bigger polynomials and seeing some of the tools that we have to see how we can split them up into their factors.